There is a story going around that someone released millions of bees into the Mojave Desert, and that a year later, the whole ecosystem had transformed.
That pilot study was just looking into the effects on sand. Now, the main study that they're hoping to do will actually take a look at the soil.
It is the kind of headline that is easy to share and easy to believe. But when researchers actually looked, they found the story had it backward. Nobody needed to fill the Mojave with bees, because millions were already living there, hidden under sand so hot it can hit 70 degrees, doing something almost no one had ever studied. And what a single year of watching them revealed changed how scientists see this desert entirely. The empty ground. Most people picture a bee as a honeybee, a stacked wooden hive, golden honey, a beekeeper in a white suit. That picture is almost the exact opposite of what actually lives in the Mojave. The California deserts hold an estimated 750 native bee species, one of the densest concentrations of wild bee diversity found anywhere on Earth, and almost none of them behave like the bee in your head. They come in shapes most people would never file under bee at all. Metallic green sweat bees, fuzzy carpenter bees, small striped mining bees, many of them tied so tightly to a single desert plant that they will visit almost nothing else. And the overwhelming majority are solitary. No colony, no queen, no shared hive. A single female digs a narrow tunnel into open ground, packs the bottom with pollen, lays her eggs on top, seals the door, and dies, leaving the next generation locked underground to wait for the right season to come. That is why the desert floor reads as empty. There is no hum, no swarm, nothing on the surface to see. The bees are already home. They are just underneath it, scattered across miles of sand in numbers that climb easily into the millions, doing nothing visible until the exact moment the ground tells them to move, which flips the whole question. For years, the story people told about the Mojave was simple: too hot, too dry, too hostile to hold the kind of dense pollinator life that keeps an ecosystem stitched together. But the closer anyone actually looked, the more that story fell apart. The Mojave was never a blank. It was a machine running quietly, on a schedule nobody was bothering to watch. The silent problem. To see why that matters, you have to understand how pollination fails. And it almost never fails loudly. Bees and flowering plants are locked into a loop that works beautifully right up until it doesn't. Fewer flowers mean fewer bees. Fewer bees mean less pollination. Less pollination means fewer seeds. Fewer seeds mean fewer plants next season, which means fewer flowers again. Scientists call this a pollination collapse spiral. And the frightening part is how quiet it stays while it happens. There is no single moment where the alarm goes off. A patch of desert still looks alive. Plants still stand, water still shows up after a storm. A few insects still move in the light. But under the surface, the numbers keep sliding, season after season, until one year there simply is not enough left to come back. By the time the loss is obvious, the door has usually already closed. And this is not just a desert problem. Roughly 3/4 of the world's leading food crops depend at least partly on animal pollinators. Yet out of the 20,000 or so bee species on the planet, only about a dozen are actually managed for agriculture. Almost all of the real work is done by wild, unmanaged bees that nobody owns and almost nobody counts. When those populations thin out, the loss stays invisible right up until it reaches a plate. The warning signs are already here. In the winter of 2024 into 2025, beekeepers across the United States reported some of the worst colony losses on record, many commercial operations losing well over half their hives in a single season. In parts of western China, wild pollinators have crashed so far that farmers now pollinate pear and apple trees by hand, climbing through the branches with tiny brushes, doing the unpaid work insects used to do for free. Humans with paintbrushes standing in for bees. That is not a warning about the future. It is already happening, which is exactly what makes the Mojave worth staring at. It is not just a place that survives brutal heat. It is a live model of what a pollination system looks like when it is stripped down to almost nothing and forced to keep working anyway. And that is the real reason a place this hostile suddenly deserves a closer look than anywhere lush and green. Hidden systems like this one are the whole reason this channel exists. So, if that is what you came for, subscribe and stay close, because what the Mojave does next is where it stops making sense. The survival window. Start with the heat, because everyone assumes heat is the enemy out here. The obvious guess is that desert bees must be tougher, more heat-proof, built to grind through a 50-degree afternoon. That is not what the survivors do. They do not fight the sun. They dodge the hours it owns. Across the Mojave, the busiest pollinator traffic bunches into the cool edges of the day. Many desert bees fly hardest in the first hour after dawn, go silent through the punishing middle of the day, then come back out in the long gold window before dark. Others push further, into dusk and past it, working beside the moths and night pollinators that handle a surprising share of desert flower visits after the light is gone. The desert does not run a 9 to 5. It runs on a thin band of survivable hours, and everything alive crowds into that band. Every other desert animal already lives this way. Kit foxes hunt at night. Reptiles bury themselves through the worst of the day. The whole place is built around avoiding noon, not beating it. The bees just follow the same rule. And here's the part that should stop you. The flowers are in on it too. A number of desert plants hold their bloom into the cooler hours, open late, and throw their strongest scent out in the evening, basically advertising to whatever is still flying in the dark. Two completely different organisms, a plant and a bee, landing on the exact same schedule with zero coordination, because the desert only allows one workable answer. And there is something uncomfortable hiding in that. For decades, researchers studied deserts the way most people work, in daylight. Cameras out in the morning, samples in the afternoon, everyone packed up before dark. If a huge share of the real pollination is happening at dawn, at dusk, and deep into the night, then the science may have been missing a piece of the story the whole time. The desert was never dead. It was working a shift nobody showed up for. The waiting game. Remember those bees from the opening, buried in the sand, doing the very thing no one was watching? They have a name, and one of them is the clearest proof that the Mojave plays a longer game than we ever gave it credit for. She is the Mojave poppy bee, small, under a centimeter, and locked almost entirely onto a couple of rare desert poppies, including the Las Vegas bear poppy. Her range is narrow, pinned to a handful of pale gypsum and clay soils where those poppies can grow, and she is fragile enough that she has been considered for protection under the Endangered Species Act, right alongside the flowers she depends on. What makes her remarkable is not her size, it is her patience. In years when the rains fail and the poppies do not bloom, the Mojave poppy bee appears to do something almost unthinkable for an insect. She opts out of the season entirely. Rather than emerge, burn through her energy, and die hunting for flowers that never came, the evidence suggests she can stay dormant underground in a kind of suspended state, simply waiting. When a wetter year finally arrives and the desert blooms, the bees turn up again in far greater numbers, as if the population had pressed pause and then pressed play. Sit with that as a strategy. She does not fight the bad year. She refuses to spend on it. She treats a drought not as an enemy to outmuscle, but as a season to skip. That is not weakness. That might be one of the most sophisticated forms of restraint anywhere in nature. And it is exactly the kind of trait that carries a lineage through decades of chaos. The kind of decades the Mojave hands out on schedule. And it raises a much harder question. If the smallest, most fragile-looking bee out here is also the one built to outlast a catastrophe, then what does that say about the bees we actually rely on? Small and scattered, because it cuts against nearly every instinct we have about strength. Out here, the pollinators that last are not the biggest or the busiest. They are small, scattered, solitary, low output. They make no honey, store almost no surplus, and ask almost nothing from a place that has almost nothing to give. On paper, by every number we normally use to rank A at B, they look like the weak ones. In the desert, that is the entire advantage. Put them next to the honeybee, the insect most people actually mean when they say bee. The honeybee is a masterpiece of optimization, bred over generations for gentleness, for honey, for easy management at scale. And it is increasingly unable to survive on its own. A parasitic mite called varroa latches on, drains it, and spreads viruses through a hive. And most managed colonies today cannot survive an infestation without human treatment. Pull the beekeeper out of the picture, and a lot of those hives simply do not make it. An animal engineered to perform under perfect managed conditions has quietly lost the ability to get through a hard year alone. The Mojave's wild bees run with no keeper at all. No treatments, no feeding, no schedule, nobody checking in. and because most of them live alone instead of packed into one crowded hive, a disease that would rip through a colony has almost nothing to spread through. They carry a different inheritance, one shaped entirely by having to make it or not on their own. That is the trade the desert lays bare. The thing built to perform best under ideal conditions is often the first to fall when conditions stop being ideal. The thing that looks unimpressive, underpowered, barely hanging on, is usually the thing that already knows how to survive without help. And once you see that trade clearly in a bee, you start seeing it everywhere. The mirror. Because it is not really about bees anymore, is it? The same pattern is stamped all over the things we build. Supply chains tuned so tight that one bad week snaps them. Cities designed only to grow, that seize up the first time the water runs short. Systems streamlined so hard that every bit of slack, every backup, every so-called wasteful margin that used to let them bend instead of break has been optimized clean away. We keep confusing efficient with strong. The desert keeps proving they are not the same thing. What lasts out here is not the polished performer. It is the small, stubborn, self-sufficient thing that never forgot how to need almost nothing. And that leaves one obvious question hanging. After a full year of watching, what did all this restraint actually add up to? 1 year later, here is the honest answer, and it is not the one the title makes you expect. The desert did not turn green. No carpet of wildflowers rolling over the dunes, no rivers cutting the sand, no clean before and after shot to go viral. Bees do not make water. They do not build soil. They do not summon rain out of dry air. What they do, what they have always done, is hold steady whatever life is already trying to survive. They make fragile things a little less fragile. That is the whole job, and it is quieter than anyone wants it to be. So, what did a year of actually watching turn up? In seasons when the rain came and the pollinators came out in force, native desert plants set more fruit and more seed. Rare specialist flowers got visited by the specialist bees that keep them alive. Small pockets of insect life ticked upward around whatever managed to bloom. None of it makes a headline on its own. But stacked together, it confirms the thing that matters most. Even in one of the most stripped-down landscapes on the continent, a working pollinator chain still throws off a ripple. The chain still fires. It just needs the right conditions, and the right bees still in the ground to carry it. And this is where the title finally pays off, just not the way it promised. Nobody filled the Mojave with millions of bees. The millions were already there, and had been for longer than anyone was counting. What changed across that year was not the desert, it was us. The assumption that this place was empty, a dead margin waiting to be fixed or filled, quietly collapsed under 12 months of evidence that it had been fully occupied and fully functional the entire time. So, yes, everything changed, not the sand. The story we had been telling ourselves about the sand. We walked in, expecting to watch a wasteland get rescued, and walked out realizing we had been misreading a living system for as long as we had been looking at it. And once a story like that cracks, the reflex that comes next is the dangerous one. The instinct to scale. Because the second humans see any sign of success, any green shoot, any uptick in the data, the reflex kicks in. Scale it. More flowers, more water, bigger. Projects, faster timelines. Turn a small, stable system into a grand rescue. It feels like the right move. Across the world's drylands, it has been the wrong one over and over. The history of forcing deserts to become something else is mostly a history of backfires. Huge greening and planting schemes have drained underground water so hard they sped up the very drying they meant to reverse. Introduced species have poisoned soils and shoved out the native plants that had been quietly surviving for centuries. In the Mojave, the pressure looks different now, but the logic is identical. Sprawling utility-scale solar farms, thrown across desert valleys in the name of a cleaner future, scrape away plant cover and shatter exactly the habitat the region's wild bees and rare flowers depend on. Even good intentions, dropped on the desert at scale, can quietly dismantle the network that was already working fine. The Mojave does not need to be rescued into looking like somewhere else. A stretch of desert that keeps its specialist bees and its rare poppies for another 50 years matters. A pollination chain that stops one more plant from vanishing matters. Small, stable, and left mostly alone is not a consolation prize. It is the win, even if it never photographs well. Which points straight at the last thing this year taught us. and it is the part that lingers. What the desert keeps. We judge a place by how much it looks like somewhere we already like. Green, lush, productive, useful on our terms. By that scoring, the Mojave fails every test. And yet, the closer anyone looks, the clearer it gets. This desert was never broken. It was just being a desert, running something we never bothered to watch. And there is one last reason it may matter, far past the sand. The wild desert bees that shrug off drought, that wait out the bad years underground, that survive with no keeper and no treatment, are carrying survival traits. Our managed fragile honeybees have mostly lost. Researchers studying insects like the Mojave poppy bee have already started mapping their genetics, precisely because figuring out how a bee smaller than a grain of rice endures 70-degree heat and years without water might be exactly what helps save the pollinators our food supply leans on. The place we wrote off as a wasteland may be holding the survival manual we are about to need. As the summers stretch longer and the droughts bite harder, the questions this desert quietly answered thousands of years ago stop sounding like trivia and start sounding like ours. That is the pattern under the whole story. Small bees holding a food web together. Night work nobody is awake to see. One dormant insect quietly deciding whether a rare flower gets another generation. None of it is loud. None of it makes a clip. But pull any single piece and something downstream starts to fall. The Mojave was never an empty place waiting to be filled. It was full the entire time, running on a schedule and a kind of patience we are only now learning to watch. That bee is still down there, still waiting, and at least now, someone is finally paying attention. If this changed the way you see the empty-looking places, the deserts and dead-looking stretches most people write off as nothing, subscribe so you do not miss where this goes next. Because the natural world is hiding far more of these quiet systems than anyone expects. And before you go, tell me this in the comments. What is a place near you that everyone calls empty or dead? And what do you suspect is actually going on out there when no one is looking?